Welcome to the another session of second PUC practical physics. So in this session we are going to discuss about the angle of minimum deviation of prism. So our aim is to find out the angle of minimum deviation of prism by plotting the graph of angle of deviation versus angle of incidence. So to determine the angle of minimum deviation by plotting a graph of angle of incidence versus angle of deviation. So first we know what is angle of deviation, then I will introduce you what is angle of minimum deviation, then we will go through the practicals. For that I consider a prism. I call this prism as A, B and C. The angle of prism that between two rectangular surfaces, I call the angle of prism as A. Let's consider a light which falls on the surface AB, and this light gets as it enters the prism, which is made up of glass. So it is going, let us say it is going from air to the glass. So I draw a normal for the surface AB. So what happens? The light will bend towards the normal. So let's say this bends a bit like this. And again, let's draw a normal here for the surface AC where the refracted light is entering. Now from this prism the light is entering out of the glass, so it will bend away from the normal, so you can expect the deviation like this. Okay, so now the angle of deviation, let's know what is angle of deviation is that. For that I take the incident light, let me call it as PQ, and undeviated incident light I represent it with dotted lines, and retraced, okay, let me call this as PQ, R and S, retraced emergent light. So take the retraced emergent light. So this angle between undeviated incident light and retraced emergent light, we call it as angle of deviation. So I represent the angle of deviation, that is delta, angle of deviation. So this angle of deviation becomes minimum for a particular angle of incidence. So our aim is that we are going to find out that angle of minimum deviation. Let's see when we will have angle of minimum deviation means. So let's again consider the prism. So let us take an incident light. I call this incident light as P, Q, and I take a normal here for this surface. Okay. So the angle of deviation delta tends to be angle of minimum deviation when this light, incident light passes parallel to the base of the prism, refracts and passes parallel to the base of the prism, this angle of deviation becomes angle of minimum deviation, and also it is coming out. So let's name it as PQ R S. So here also take a normal the surface. Okay, let's take the undeviated incident light, retraced emergent light. So this becomes the angle of deviation, that is dm. So in this experiment, our aim is to find out this angle of deviation for a particular angle of incidence to get this angle of minimum deviation. In this case, the angle between incident light and the normal is angle of incidence. So this is refraction at first surface, I call it as R1. The refraction at second surface, I call it as R2. That is angle between refracted light and the normal is angle of refraction, and the light which is coming out, emerging out of the prism, the angle between normal and the emergent light, I call it as angle of emergence. So this angle of deviation, that is delta, becomes angle of minimum deviation. In that case, angle of incidence will be equal to angle of emergence, that is refraction at first surface will be equal to refraction at second surface. So these things may happen at a particular point. So let's perform this experiment. In order to do this experiment, the operators I am making use the prism. It's a 3-dimensional object. Then thermocol and plain papers to fix the papers on here, and ballpoint pins. You will get to know why we are making use of those things. Let's start with the experiment. I have fixed this white sheet into the thermocol using the ballpoint pins. I am placing the prism here. I draw the lines to mark the prism position. Let's take like this. Here we are experimenting for different angle of incidence. I will be starting with 35 degree. Let's see, exactly at the midway of the prism, I would like to draw the normal. So the length is of somewhere here we have the midpoint, and that's it. Okay, this dotted line perpendicular acts as the normal. For the first trial, I am placing the angle of incidence to be 35 degree. So here we need to make a careful step that the 0 should be on the normal, because the angle of incidence is the angle between normal and incident light. I will be starting with 35 degree. So here we have, let's complete this line. Okay, now place the prism in its position. I place the ballpoint pins. Let the distance be around 3 to 4 centimeter. I am placing 2 ballpoint pins. Okay. It will be like this. Try to place them at same height and on the same line. Now I will be observing that 2 ball points from this other surface on this side, that is they are getting refracted. So the angle of incidence is 35. What happens here is the light falls on that pinch and that gets reflected through this prism, they get refracted. So as a result, they won't be in a straight line path. When we observe the pin from this side, the refracted side, so you can able to see the pins here. Now what we need to do is, we need to place the ballpoint pin in the path of the refracted light in such a way that the pins, the new pins that we are placing on the refracted side should be coinciding with the object pins. So let's do this. Now if you observe closely, you can able to see this this refracted pin. I am placing this pin in the path of the refracted light. So I am placing in such a way that it exactly coincides with the object pins. So we cannot able to see the object pins now, because this is exactly in the path of refracted light from the object pins. For reference, let us place one more from a distance of 2 cm away from it. Okay, this completes the first trial. Let's take out. Yes, we have completed the first trial. I have placed the pins in the path of refracted light. So I am just removing it. Let me complete this ray diagram. Okay. I extend this undeviated. Take the incident light. Now this refracted light, or you can say the retraced emergent ray. So this angle is the angle of deviation. So let's find it out. So place exactly wherever these two lights meet. I'm placing this. Let's find out the angle between incident light and the emergent light. So 10, 20, 30, 40, it's 44. The angle of deviation for an angle of incidence 35 is 44 degrees. So this completes one trial. So we repeat this process for the other angles like 40 degree, 45. So let's proceed. Okay, let's go for the second trial. Marking the prism. This will act as the normal. In this trial, let's take the angle of incidence as 40 degree. So that's the angle between normal and the incident light. So here it is 40 degree. Let's draw this incident line. Okay. I place the pin in the path of incident light. Need to be equidistant from the prism. So now I place the prism. This is for 40 degree. Okay. Now I observe that pins on the incident light, and we need to place this. I'm going to place this other two pins on the other side where we find the refracted light. So you can see on this side of the prism, you can able to see the refracted light, through which we can observe that pin. Now we place this ballpoint pins in the path of refracted light, which exactly coincides should be in such a way that when we place this pin exactly which submerges the first pin, so we can able to find out this angle of deviation. Let's do that. Yes. So now let's find out the angle of deviation. So you take out the prism, mark the position of the pin. So let's take the undeviated incident light here. Draw a line through the two positions of the pins. So this the angle between undeviated incident, as I said earlier, and retraced emergent light. So this is the angle of deviation. Let's find it out. The point where this incident light and emergent light meets, they replace the protractor. So now let's find it out. Yeah, 20, 30, 45. So the angle of deviation is 45 for this. The angle between undeviated incident light and the retraced emergent light is 42 degree. So we have made the trial for 35 degree and 40 degree. We continue this experiment for other degrees like 45, 50, 55, and at 60 degree we will stop it. So we find out 6 different angle of deviation and plot a graph as per the process. So there we can find out the angle of minimum deviation. So let's do that. For different angle of incidence starting from 35 degree to 60 degree, we have calculated the angle of deviation. Now we will plot the graph of angle of incidence versus angle of deviation and find out the angle of minimum deviation. Let's start. So the origin along x-axis I'm taking the angle of incidence. Here I'm taking angle of deviation. Let me write the scale. X-axis 1 unit is equal to one of the easiest way of writing the values is that find out the difference between values here. So there will be 40 to 35 5 units, 5 degrees 45 degrees to 40. So you can see that 5 differences is there. So it's better for 1 unit take it as 5 degrees, and y-axis 1 unit is equal to, observe it is varying from 37 degree to 44. So better to start from 34. Two divisions will be better. You can see 44, 42, 2 divisions, 42 here, 3, 2, and it's going like that. It's better to start from taking a difference of 2 degrees. So now, using this scale, I take 1 unit as 5 centimeter for my reference. So 1 unit, x-axis 5 degrees. Let me start from 30, 35, 40, 45, 50, 55, 60. In the same way, okay. So starting from 37 is there. So let it be 36. Let it be 34, 36, 38, 40, 42, 44. Hope that's enough. Okay, let's mark them. For 35 degree of angle of incidence, the value is 44. So here the first point for 35 degree of angle of incidence we get 44 by angle of deviation. X for 40 degree is 42. This is then for 45 degree it's 39. It's halfway between 40 and 38. So here. Next, for 50 degree, you are getting the value 37. Next, 55 degree, the value goes to 40. Then for 60 degree is 41. Okay, let's complete this by joining all the points. So this is the graph of angle of incidence versus angle of deviation. You can see on either side there is two angle of deviations for different angle of incidence. At one particular point we have the minimum angle of deviation, that it corresponds to 50-degree angle of incidence, and the value is 37. The angle of deviation is coming out to be 37. So our aim of the experiment is that to find out the angle of minimum deviation of the prism, given prism. So you can able to do that. Once we find out of experiment, if you think we can able to find out the angle of prism. The prism is made up of glass. You can also able to find out the refractive index of that material which is made up of prism by making use of the formula n is equal to sine a plus dm by 2 whole divided by sine a by 2. So we can able to find out the refractive index of the prism by finding out here dm refers to angle of minimum deviation. So we calculated the angle of minimum angle of deviation of prism as 37 degree. That's the result of the experiment. Angle of minimum deviation is equal to 37 degree. So this completes the experiment.